The project I want to talk about today is these ship variants. Actually, I meant to show this to you in the game. So let me share this window again. So we're back in the game. Let's see. If I press, now currently it's set to the B, N, and M keys for no particular reason other than that they're completely free on my keyboard. So if I press M, you will notice that the nozzle on my ship has changed. Now it looks like I have this big rectangular barrel coming off. When I shoot, it will give a lot more kickback to my ship. I also shoot a lot more slowly, but I have a lot more powerful of a bullet. So this will do a one hit. It might even one hit the yellow. I don't remember. No. But you see that the bullet actually survives and bounces off, or keeps going in that case. So this is the sniper variant, and this is based on a variant in Diepio, where it fires slowly but has more powerful bullets that tend to go through an object and last longer. If I press the N key, now I have this sort of wider nozzle on my ship, and if I hold down left click, this is basically based on the machine gunner from the Diepio game. So it shoots very rapidly, but the accuracy is a mess, and it's not particularly high damage or anything like that. If I hit the B key, I become this spiky ball, and I don't have any sort of barrel or lead indicator on my ship. If I click, I cannot shoot anymore. But what I have instead is I've increased my armor and the damage that I do from running into these experience bricks. So this is basically the rammer from Diepio, where my strategy is to just run into various things. So those are the three variants that I've created, and I'm going to share this code with you so you have access to those variants. If you've played Diepio, you know some of them. Like there's one ship that fires in 2 directions. There's a ship that fires in 4 directions. There's a ship that fires in 8 directions. So that's kind of a basic one that you can do. And then there's weirder things. There's ones that fire like seeking bullets. How do we actually implement one of these variant critters? So the B key and its code is right here, N is right here, M is right here. And these are all pretty similar. So the first thing I do is I say players, new variable equals all critters, that's my list of all my critters, bracket camera index. Now, initially, this is just going to work on the player itself. We can fix it later so that any different critter, like one of the NPC critters, one of the computer-controlled ones, can also change its type. But for now, it's just the player that's going to change. So whoever the camera is focused on is the critter that's going to change when we press this key. So I could actually change the camera over to one of the other NPCs and change its type, but that's not what I want to do right now. So the player and all these critters have a revert to baseline function. Initially, I wrote it for the power-ups because the power-ups make adjustments to the various critters' attributes. So when that power-up expires, we want to put them back to their normal stats. So that's what this function does. Now, this is actually something you may not have seen before. What I'm doing here is I'm setting a function equal to a different function. Imagine someone transferred their phone number to a different person. A call to that same phone number now calls a different individual. And that's what's happening here. So revert to baseline used to be a different function before this line of code. Now we're saying the revert to baseline is actually a call to become rammer. So this is the rammer ship that doesn't shoot anything and has some extra armor and deals some extra collision damage. So now whenever I revert to baseline, I'm actually going to call become rammer. And this is important because in order to change my type, I need to consistently be this type. So anytime that I reset, I need to reset to this new type. So that's what I'm doing here when I set a function equal to a different function. So this line of code is how you actually become a rammer. And then calling the function makes it so that we get our attributes set to that rammer's attributes. And it's the same thing in each of these other two down here as well. So if and when you create a variant of your own, we'll have to, I'm just using this for testing, right? We'll have to pick a key on the keyboard, and we'll call something like this, where we're gonna take the attributes of that new variant and make it our baseline. Okay, so let's actually look at like a function like become rammer. Those functions are in ship.py. So I'm in ship.py now, and you can see I have a function that's just become rammer. You're gonna, if you want to create a variant, you should write one of these functions. It's not too long, fits on one screen, and it's a lot comments. If I scroll down, you can see like become machine gun is also one function. It fits on one screen, and then become sniper is one as well. And I'm going to talk about what sort of code I have here. So the very first thing that you need to do, no matter what, is call revert all. Now I know I had a revert to baseline, and now I have a revert all. These are not great function names. I was struggling to come up with better function names. Revert is also basically where we're resetting to our baseline values. So what happens when you become a rammer is you revert to all your baseline values, and then the rest of the code, oops, sorry, I didn't mean to scroll that far. The rest of the code is adjusting those baseline values for the particular values that a rammer is going to have. So for example, it sets its shape to a spiky shape, and I'll show you the different shapes that are available in a second. It sets its draw heading variable to false, right? The heading is, I know it kind of looks like a gun or a barrel on some of the ships. The variable names I'm using are heading for it. Can it shoot? There's a variable that you can just set true or false to allow ships to shoot or not, and it sets it to false. The rammer doesn't get to shoot. That's sort of the trade-off that you get. But it does deal double the damage in ship collisions. So every upgrade of your collision damage is actually going to now deal double damage. And this is a really long line of code that got wrapped onto the next line. Right? This is all one line right here. The way this works is you'll notice self.x's is repeated a whole bunch there and there and there and there. X's is also a terrible name. I was trying to keep things short because a lot of my code was running off the end of the line. This is your list of attributes. Every ship, every critter is a ship. It has lists of attributes, and X's is the name of the attributes. To index into this list, we use a particular variable name like collision damage index or hit point regeneration index or shove index or armor index. Now, all these indexes, these indices, are in constants.py. Yeah, you can also see in here the different shapes. So I have circles, rectangles, triangles, pentagons, and then the spiky shape. And if I scroll down, yeah, so these are the attributes that are all in the X's list. So we have acceleration, which is effectively speed. It's actually implemented as acceleration, but the friction makes it seem more like a speed. Hit points, collision, refire, all kinds of stuff for your bullets, regeneration, more bullet stuff, recoil, vision radius, you can actually change. You could have a special all-seeing variant of a ship or a special variant that's just blind. Either way could be kind of interesting. The friction index, how much friction is applied to the ship, and so on and so forth. And you can experiment with all these. But these are the indices that index into this attribute list named self.x's. So on this first line of code, right, we just get that value with that index, and we set it equal to itself times 2. So great. Now we have double our collision damage. The next line, we increase our hit point regeneration for the ramming ship. So we set our hit point regeneration equal to the default value. Sorry, actually, it's not equal to itself. It's equal to get default, which is important because, like, if we change the type of our ship while we have a power-up active, then if we just set self.x's collision damage index equal to self.x's collision damage index times 2, but we had a power-up active, we could like have a really huge collision damage that now we're doubling and everything is screwy, right? So we call this get default function that is careful about actually getting the default value. So anyway, like I was saying, the regeneration, I add 0.01, which is actually semi-significant because that is happening 60 times per second. It's happening every frame. The rammer doesn't want to shove other ships away, right? It wants to get right on top of them and just keep slamming into them. So it doesn't shove other ships away at all. We just set the shove index to 0. And it takes 10% less damage. So it only takes 90% of any damage that it's given. So that's what armor does. Armor is actually a percentage of damage taken. So low armor, confusingly, is actually best. It's actually like damage taken, but again, I was trying to keep some of these variable names a little bit short. Obviously, I failed in some cases, but that's the rammer. And so hopefully you recognize that this is pretty well set up for a lot of creativity already in the different ships you could create. So let me talk about the other ones just briefly here. So become machine gunner, it reverts to default. It draws a special heading indicator. And again, this is where we're setting a function equal to another function. And I'm going to show the draw heading machine gun function in a second so that you can maybe make your own barrels or heading indicators, whichever you want to call them, for various ships. You can make them look like different things. You could also change the radius in here too. You could make your ship bigger or smaller, which has been done in the past. So since the machine gun fires so quickly, we want it to have low recoil. So we divide its recoil by 6. We want it to fire very quickly. So the refire delay, we divide by 4. So it's going to fire 4 times faster. Bullets should not last as long. So the sniper has like the really long range bullets, but the machine gun has kind of like short range bullets. It just has a lot of them. So the lifespan of a bullet is divided by 1.5, the longevity of a bullet. And this is just a time and number of frames. The bullets penetrate less. So this is basically that like the bullet is more likely to just die as soon as it hits a target. There's a max function right here. It's the larger of the number 1 or the default -1. The reason for this is because bullets initially start off with 1 health. So as soon as they hit something, they die, right? So they don't penetrate into any object at all. And I forgot about that. And then when I subtracted 1 off of their health, the bullet just like disappeared immediately because it was immediately dead. So now it's whatever is larger, 1 or the default -1. And then they spread a lot more. And this is kind of a fun one to play around with. The bullet spread is, it's just basically a random angle in radians, right? Here's pi right here. It's a random angle added to the bullet's direction. We're adding an angle of pi over 6 for the machine gun. Sniper is then going to be pretty similar. It's almost the opposite of the machine gun in some ways. So I have a different heading, different barrel. That's the draw sniper heading. High recoil, so we triple the recoil. Slow refire, so the refire is multiplied by 2, so it takes twice as long to shoot. Bullets last 2.5 times longer. Bullets they penetrate more. They have +4 more health, and they don't spread at all. The sniper has perfect accuracy. So these are the 3 default ones, not default. These are the 3 like initial ones that I added. These are actually really fun to create and play around with. So I strongly encourage you to make one of these. One thing I wanted to add that I forgot to say yesterday is in my AI for testing class, you scroll up to the top, there's this weird looking list. It's just formatted poorly, but it's a list called self.level choices. And then it's got a bracket and it's got various indices of attributes that you can level up. So what's going to happen is as soon as a non-player character critter gains enough experience to level up, it's going to look at the first item in the list and it's going to choose that to level up. So my critter, all my critters actually have the same level up order. All my critters level up bullet damage first, again level up bullet damage second, hit point regeneration, speed, total hit points, etc., etc., etc. And they go down the list. Now, once they get to the end, they just stop leveling up, which is kind of unfortunate. But this is a really easy way to choose a level up scheme for your critter. So if I go over to the F sprite, a couple different things here. There's the heading indicator, which I'll talk about. And then there's also the body shape, right? The rammer ship has that spiky body shape. So let's talk about various things here. So drawing the circle is easy because we just get to use Pygame's ellipse function. Drawing a rectangle is easy because we get to use Pygame's rectangle function. Drawing a triangle is a little bit more sophisticated. What should be the angle to the various points on the edges of my triangle? This is not the angle of the corners of your triangle. In fact, let me make this very, very clear. Here's a triangle. That angle is not the angle of any of these corners. That's not what you're basing this on. I know that's typically what we're interested in math class, but what we're doing is all our critters, they start with a point in the middle. We're using that angle to go outward to each corner. The way to go to one corner, the way to go to another corner, and the way to go to the third corner. So the angle that you actually need to use if you want to make your own shape is this angle right here, right? Because we start off, pointing towards one corner. We add this angle in to go to the next corner, and then we add that angle in another time to go to the third corner. And then I just have a for loop for I in range 3, because it's a triangle, 3 corners. I calculate my y value based on my starting y value plus the radius. Oh yeah, sorry. The starting y value is up actually in the upper left corner. So to get the middle of the shape, I got to add in the radius. So upper left corner plus the radius gives me the middle. And then the radius is how far I should extend outwards times the sine, the y, because sine's associated with y values, of the angle plus the angle adjustment. The I times c here is the angle adjustment, right? Here's the angle. And we multiply it by I. So the first time it's at angle 0, and then 1 times this, and then 2 times this for that third corner. And we append the points to a list, and we use Pygame's draw polygon function to draw, to connect all of those points. The Pentagon is very similar. I use a different angle. Notice instead of dividing by 3, I'm dividing by 5 here. But these 2 lines of code are exactly identical to these 2 lines of code up here, right? Figuring out how to go outward to those corners. Sorry, and actually the append is also identical, as is the polygon draw, right? So the only difference between the drawing of the triangle and the drawing of the Pentagon is this 5 or this 3, which actually makes me realize that I should probably just make these the same function and add an argument that's like corners. Anyway, though, not right now. All right, draw body spiky. Now, some of this code is similar. Like this code right here is pretty similar to these 2 lines up here. But what's different is every other time you go outward to the edge, you want to go more or less far to get that jagged spiky shape. So I use I mod 2 basically to separate my evens and my odds. And then I have these lines right here to determine how far outward from the center I'm going to draw. This is the longer one, right? I do my radius times 1.2, 20% more than my radius. But when I is even, I do 20% less than my radius. And so when I go and connect these with a line, when I make a polygon, I'm going to go out to a further distance from my center, longer radius. And then I'm going to adjust my angle a little bit. And then I'm going to come back in 20% less than my radius, and then out, and then in, and then out, and then in. And it makes that jagged, like sawtooth look on the sprite. So you might play around with this if you're interested in, sawtooth functions. A really easy adjustment to this is you can use random and make like random length spikies. And then the heading indicators. So this is initially the little circle that just shows you what direction your critter is facing. But then we can also make it like the machine gun's like cone shape, or the sniper's rectangle shape. It's actually pretty hard to write a for loop for this. It would actually be a for loop that only loops twice for the machine gun or for the sniper. All of this code would be inside the for loop. So I guess it would be half as long, but there's still some other adjustments to make. I'm gonna tell you what this code does, and you can dig into it if you want. It's just using math.cosine and math.sine. Our critter is facing this direction. That's its angle currently. The sniper has a barrel that looks like this. If I want that to be my barrel, so basically off to the left of my angle to here, and off to the right of my angle to here. So that's one pair of coordinates that I'm going to find. And then I'm also going to find another pair of angles, one off to the left, but less off to the left, but with a longer radius, and one less off to the right, less in terms of angle, but more in terms of radius. And that's how I'm going to find my 4 coordinates that will let me draw then a rectangle. I'm not using the draw rectangle function. I'm using the draw polygon. The reason I'm not using the draw rectangle is because Python can only draw rectangles in this orientation, the same orientation I can get in this whiteboard program. It can't draw rectangles off at an angle. right? It can't draw this. I mean, not with the rectangle function, it can't. So suppose you don't want to do something like the sniper, you want to do something like the machine gun. Probably you can already imagine how this is going to work. We're going to do something very similar. We're going to get an angle slightly to the left and at a particular radius, and an angle slightly to the right and at a particular radius. And then we're going to do the same thing, but at a greater angle and a larger radius. And the same thing over here, a greater angle to the right and a larger radius. And that gives us the 4 coordinates of our edges of our barrel or indicator. And then we can use the draw polygon function to draw that shape. Your barrel doesn't have to be 4-cornered, right? It could be 3-cornered. It could be a dozen cornered. It could look like a variety of different things. There's a lot of opportunities for creativity in designing the various ship variants. And I wouldn't concern yourself necessarily with like balance so much. I mean, unless that's what you're interested in. Partly because this game is already so unbalanced, it's going to take some work to get it into some sort of fair state. But also because there's a lot of opportunity for different creative critter designs that you could make.